Good afternoon, my dear student. Here I am Dr. Vishwajit Gain, Assistant Professor, Department of Chemistry of your college, Dr. Sudit Chandrasoor, Institute of Technology and Sports Complex. Today, in this class, we will discuss about the band theory of solid. So today we will discuss about the solid and its conduction, that is movement of the free electron in the solid. So before going to the details, I want to say about the theory, that is band theory of solid. Here in this level of your study, it is not very much required the band theory in details, but yes, it is required a preliminary idea about the band theory. So band theory is basically, if I consider the very simple system, then suppose there are the two energy state. So if there is a possibility of overlapping to each other, like shown in this figure, so when the energy level are come closer, then there is a possibility of transfer of electron from one system to another system. Or if the system is same but the two energy level are different but they are very close to each other, then the transfer of energy or transfer of electron is possible. So very simple, in case of the A, the energy transfer or the transfer of electron from one energy to another energy is possible. But in case of B, that is one energy state to another energy state, is not possible because the energy difference is very high. So it is not possible. So band theory tells us the possibility of electron transfer between the two energy state. Now there will be lots of criteria and other thing about the fulfill the condition to be a metal, to be conductor or transmission of the electron, etc., and insulator. So we will discuss it in the next few slide. So now we are going in details. So first of thing, what is band gap? What is band gap? So band gap, if you just before I going to the band gap, I want to say something. The last completely filled energy state of a particular metal or anything, last completely filled orbital or energy state, because when we are considering suppose iron, so there's no single iron, because no single iron atom or metal, but there is lots of metal. So when they are in the summative state, so there will be not a single atom and single energy state, but there will be lots of atom and lots of energy state. So a collective number of the energy state is possible. So if I consider the last completely filled orbital of iron, then we will call it valence band. So this is a band, like if I drag two thing and two lines, then there will be one is the valence band, that is mainly the completely filled electron at temperature T, that is absolute zero temperature. But there will be others orbital, atomic orbital. So when they are in the summative state, there will be not a single atomic orbital, but there will be a number of the atomic orbital. So ultimately they form again a band, and that band are not occupied by electrons, so they are basically empty. So this band is called conduction band. So first, so in metal or any other type of thing or element, then there will be two possibility. Then one is the valence band, another is the conduction band. So conduction band means higher energy state, and valence band means lower energy state. And valence band is the filled, and conduction band it may be filled or may not be filled, or it may be empty, because it will be depending on the possibility and depending on the temperature. So the conduction band, I just told you, can be empty and partially filled depending on the situation and depending on the element. Now the band gap. So very simple, the energy difference between the conduction band and valence band is called the band gap. So if you look to the picture, so here this is the valence band, that is denoted by orange color, and white color is denoted by conduction band. So this difference, that is 9 electron volt, is the difference between the valence band and conduction band. So this is the band gap. Now depending on the situation and depending on the element and other situation, depending on the band gaps specifically, the solid can be divided in three categories. Again I am saying, depending on the element, depending on temperature, depending on the environment, depending on the complex, depending on the situation, the solid, because we are mainly dealing with the solid, so solid can be divided in three types, which are very known to us. First one is the solid can be behave as a conductor. Another thing, that is semiconductor, and another is the insulator. So three possibility. One is the conductor and its opposite is insulator, and in between these two another is the semiconductor. So conductor means it can conduct electricity, very simple terms, or there will be a transition of the electron, a transfer of the electron. But in insulator this is not possible, the electron cannot move, so all electrons are tightly binded. Now in case of the semiconductor, so they are not completely good conductor and not behaves as a semiconductor, so they are in between these two. Now we will decide, or we will find out what or which type of the metal will behave as a conductor and which type of the metal behaves as insulator and the element as a semiconductor. So from this picture or from our common discussion, it is very clear in conductors there is very negligible band gap. In conductors there is very negligible band gap, so the energy level between valence band and conduction band are small, so that's why there will be transition of the electron is possible, or the electron are very much easily available in the conduction band. So if the electron are present in the conduction band, then it will be conduct the electricity. So as the gap between the valence band and conductance are very small, so there is a possibility of conduct electricity or the transfer of the electron. Now in case of insulator, this gap is very much. So in conduction, so student, in conduct, in case of the insulator, it is just opposite of conductor. It is not actually opposite, but it is just the energy gap is low, and in case of the insulator energy gap is very high. But in case of semiconductor, this energy gap is moderate, so at a particular temperature they can behave as a conductor because the valence bond can be shifted to the conduction band, so then they behaves as a semiconductor. So from this figure you will be very clear about which one will be acts as a conductor, which one will be act as a semiconductor. So here this is the valence, conductor. So if you consider the orange block as a valence band, and that is the box is lined by blue color is the conduction band, then we are saying that there is a overlap between the conduction band and valence band. So there is a very easy possibility of the take position of the electron in the valence band, valence band as well also conduction band. So as the conduction band, as the electron are present in the conduction band, so they can conduct electricity or they can transfer electricity very easily because the electron are loosely bounded. Clear? So that's why they are acts as a conductor. So this conductor is mainly the metal. So in case of the metal, the valence band and the conduction band are overlapping each other. But insulator, here the valence band energy and conduction band energy, that is gap, is very very high, so there is no chances of overlap between valence band and conduction band. So there's obvious that if you increase the temperature, there is no possibility of the electron in the conduction band, and if there is no electron in the conduction band, then there is no question of the conduction or transfer of the electron. So this type of the material will behave as a insulator. So here in this case, when the energy difference between these two band is greater than 9 electron volt, then we can say this is insulator. But in case of the semiconductor, there is that the valence band and the conduction band have a energy difference of nearly about 1 electron volt. So yes, they are two separate band and they are not overlap each other, but yes, they are very close to each other. So now if someone increase the temperature, then the electron from the valence band can shift or transfer to the conduction band. So now if the electron are available in the conduction band, so then it can behave as a conductor, or basically not perfectly, but it's a very feeble current transfer is possible. There is weak current. Now if the orange dot from the conduction band is removed, then there will be vacant place. So then again from the valence bond, some of the electron will reach to the conduction band and a feeble current will be continued in the circuit. So this is the main theory or concept in the band theory about the conductor, the semiconductor and insulator. Now we are discussing in details with taking each of the thing very elaborately. Now if you think about the insulator, here the conduction band is empty, and if you apply electric field in this type of the solid, the electron in the valence band cannot participate in the transport because the energy gap is too high. If you supply energy, but still it is not possible to reach the electron in the conduction band, and the electron in the valence band do not participate in the current, because we have already discussed about this, because only conduction electron in the conduction band can participate in the transfer of the electricity or make current. Classically, electron in the electric field accelerate, so they are acquire kinetic energy, and such states must be available, that is empty allowed state, because I have again say that the conduction band is empty, so there is no question of the current, but no such state are available in valence band. Consider a solid with a half filled conduction band. Half filled conduction band, because there's a not so much electron present in the conduction band, but some number of the electron is present in the conduction band. So if the electric field is applied to this solid, then the electron in the conduction field can participate in the transport, because as there is a electron is present in the conduction band, and since there are the plenty of empty allowed state with energy just above the Fermi energy, so they can participate in the transfer of electron, and so electricity, and this metal can be acted as a conductor. Band overlap, I have already told you, if the band overlap takes place, then there is a very easy to transfer of electron from valence band to conduction band, then it is behaves as a good conductor. It is an electron level and then available. So there is a quality difference between metal, semiconductor and insulator, and you have all have idea what are the difference. So the highest energy band containing electron is only per field for metal and acts as a conductor at even a very low temperature, because the metal can conduct electricity at normal temperature. insulator and semiconductor. So these have some difference of the energy. In case of the insulator, the energy gap is very high. So at high enough temperature, a fraction of the electron can be found in the conduction band and therefore participate in the transport. So in case of the semiconductor, a number of electron can reach to the conduction band, and so it's a feeble current. But in case of the insulator, no such transport is possible, so it does not show, or it does not show any electricity. So student, that's all. I think if you I think you understand the band theory and the concept of the uh, conductor, semiconductor, and insulator. So in the next class we'll discuss about the doping and how the efficiency of a semiconductor is increases, because semiconductor is very important nowadays, because semiconductor material is used in our everyday life, like in electronics mainly. So in each cases the semiconductor metal is very important, so we want to increase the current but not so much high. So in that case we are doping some element to the semiconductor, that is in silicon, germanium, etc., this type of the element. Then we can reach our target and we make our essential thing without any difficulties. So student, I hope that you enjoy the class, and I am waiting for your question or any queries. So thank you very much for your kind attention in this class. Thank you very much.